Sciences. And Amit sir, Dr. Brijesh is a senior professor and head Department of Chemistry, Madhav Science College, and currently is president of Association of Chemistry Teachers. Sir.
Great to know about you and being here, sir.
Thank you. So nice of you.
And I also would like to request you to visit our campus and join us physically so that we can.
Yeah. Now we are into good times now, so it is possible. Definitely, sir. I would like to come.
Most welcome, sir.
Thank
right.
you.
Yeah.
Shall we start, sir? Jamin?
Yeah, proceed.
Yes.
Yes.
How many participants have joined?
Yes, sir. Nihal, please.
90 plus participants.
Okay, great. Very good.
Yes, Jamin, please start. Thank you, sir. Jamin?
Okay, sir. So I'll start today's session. Very good morning to everyone present here today. I welcome you all today on second day of National Chemistry Week 2022 celebration. Today we are very happy to have with us Dr. Ajay Gupta, Director of Research and Development, Ganpati University, and Dr. Amit Parikh, Dean Faculty of Science and Principal, MUIS, Ganpati University. As we continue our lecture series today, we have very anticipating lecture today by Dr. Brijesh, who is the President of Association of Chemistry Teachers India. Sir has received MSc, MPhil, and PhD, and after receiving PhD, Sir received postdoctoral fellowship from National Research Foundation, Pretoria, and worked in the Department of Chemistry, University of Durban, Westville, Durban. Sir is the honorary coordinator and panelist of various national and international associations and organizations, and lifetime member of Chemical Research Society of India and Indian Council of Chemists, Agra. Sir has 80 plus research publications under his name, and his research interest lies in green chemistry and sustainable science and advanced oxidation process. Sir is actively engaged in doing extensive work on training programs for learning and teaching creativity using various models and understanding and identifying students' misconceptions and learning barriers in the concepts of chemical bonding. Sir is working on novel method of teaching and phenomenon-based learning. Today, Sir will be delivering his talk on Serendipity in scientific discovery. So it is with great pleasure I invite Sir to deliver his talk. Please, Sir. Sir, please, you can start.
I am audible? Dr.
Yes, sir, you are audible. Yes, sir.
Yes.
Okay. So, Dr. Kayur, I am supposed to start?
Yes, sir. Yes, sir.
Yes, sir.
Okay, thank you very much. Thank you very much. So nice of you, Dr. Kayur Bhatt, for giving this opportunity to speak to your students, particularly your MSc students and maybe research scholars. And thank you, Dr. Ajay Kumar, Dr. Amit Parikh, sir, for having given this opportunity. In fact, last month, I was passing through Mehsana. I was going to Ahmedabad, just driving, I passed through Mehsana, and there, I saw, heard about your university, and I'm in touch with Professor Kayur Bhatt for quite some time, So that really got attracted towards your university. And when I received a call from Dr. Kayur, then I thought, definitely I should avail this opportunity to speak to students. And it's a chemistry week. So I wish you all the best. Even in our institute, we are doing that. And I'm happy to speak. So when I was thinking, what to speak, then I thought instead of going for anything related to syllabus, why not to celebrate science in general and chemistry in particular. So therefore, I chose this something, just to interact with the students and to let them know about the beauty of the serendipity. So it is visible, my slides?
Yes, sir. Yes.
Okay. So boys and girls, I'm really happy to speak to you about serendipity. I understand, you might be knowing about serendipity, but I will just express my way of looking at the things and the scientific discoveries and how, the great people, those who have discovered and invented various important things for us, for the society, how did they work, and how they got stumbled, how they were looking for something and they got something very important. Just in the very inception, I just give you the meaning of the word serendipity. That is finding something good without looking for it. Just beautiful definition, as if, you are engaged with something, but at the same time, you got, which in fact you were not looking for, but whatever you got, whatever you discovered was maybe more important than what you were looking for. So that is serendipity. This is, see, the size of the physics book, So they say, the physics, if the Newton slept under a coconut tree, what would happen, instead of the apple, if the coconut had fallen on the head of Newton, just on the lighter side, so probably the size of the physics book might be of this size, we can understand. Okay, so let us start with one of the slides, look at here, what is this? It looks to be a very, very huge machine. Okay, just look at here. And this is a gentleman, I just let you know about what he did. So this machine, which I showed you, has a weight of 300 kilograms. And when it works, it had to be water cooled. And the cost of this machine, in terms of the today's dollar cost, is around $52,000. I mean, it's a huge cost. It's going to be a very, very costly machine and very heavy machine at the same time. And I will let you know what, in fact, it is. So how the story goes, scientists invented the magnetron during the World War II. You might be knowing about the magnetron. It is a device which emits microwaves. And what is the application of microwaves of that time? The British Armed Forces used this instrument to detect the incoming German planes. So this was the war purpose of that time during the World War II of magnetron. Then what happened? When the war was over, the scientists, they continued to improve the magnetron. And the gentleman I showed you is Percy Spencer. And the story is around 1946. When in 45, the World War II was over, and the Percy was working on the improvement of the magnetron. So what happened, see, so when he was working on one occasion, he noticed that the candy, the chocolate bar in his pocket had melted when he was working with the magnetron. This was one observation of Percy Spencer. Then he tried another experiment with popcorn. Okay. And when it began to pop, Spencer immediately realized and saw the potential of this revolutionary process. This is, see, try to understand. Magnetron, a machine for the use in the war, okay, for the detection of for the interception of the planes. But this man, when he was improving, he found something very different. He was not, he didn't want, to melt something, or he didn't want to, to have the popcorns to pop up, but this happened, and with this kind of deviation from the normal study pattern, Spencer realized that something different is happening, and this observation has to be utilized. And today, I just tell you, I'm talking about the microwave oven, which almost, the family we are using in our kitchen every day, which is a very, very small instrument, very useful instrument, and these days, even it is very cost effective also. So this is one example that how Percy Spencer, who was working on something else, he was trying to do something else, but when he found some observations, how simple it is, see, instead of Spencer, somebody else would have been there, and the candy or the chocolate got melted, what he would have thought must be, like it was like that, or it is very hot today, is it not? And therefore, it got melted, and let us do our own work. But this gentleman, he stopped he had a pause, and he went, see, and the results, like this was something kind of a severe deviation from what he was doing. but he paid attention to that. He honored the event happening around him, and he realized that something different is happening. So with this, this is one example, like how the microwave has come into existence. And this is the microwave oven for our kitchen. So what I was showing, see this machine, such a big machine, and how the technology evolved. And this is how we have a very small machine, a very small, a box kind of microwave every kitchen has. So this is one example of serendipity. Okay. How the word, sometimes we have to look at that also. So the story is that the three princes of Serendip is an old name for the country we call Sri Lanka. So the story says that how the three traveling princes repeatedly made discoveries about things that they had not planned to explore, and all surprised them. So there is an element of surprise. At the same time, they discovered something which they were not looking for. So the Walpole created a new word, serendipity, to the accidental discoveries. But accidental discoveries, okay, it is something very interesting. But today, definitely, we'll try to pin on those things, those characteristics, those observation skills, that can be inculcated also. It is not, of course, there are certain characteristics which are, they are natural, they are innate. But at the same time, this is a kind of a creativity. And in the national education policy, creativity, critical thinking, communication, and collaboration. So I will just show how it is more important than before. And it is possible the young students, those who are studying in undergraduate or postgraduates, you can learn out of it, that how can you will be more observant. The fact that is discovered is a part of nature. That is one thing, see, any discovery when comes out, it was already there, and many things, many things will be discovered in coming years. So they are already in the nature. They are hidden, from us until a scientist uses suitable procedure for its revelation. It is hidden, it is covered, and it is unveiled, unveiled. Something is covered and somebody comes, a man of wisdom, he reveals that, and something beautiful comes out of that, which is of great use for the humanity in various fields. Okay, so this is very important. Who can do serendipity? Not only the great people, but anyway, we can also learn it. And the ability to see that unexpected results may be significant. This is a very important takeaway from today's talk, that suppose you are a science student, you are doing some experiment, and you are expecting a particular kind of outcome results, but even suppose you are getting some deviation, the results are not expected, then they are very significant. That result may be very important. An interest in finding an explanation, and whatever deviation and what are the different results you are getting, you have to have an interest in finding the explanation that why you are getting the results which are not expected. The determination to investigate, and definitely you have to have a determination to investigate what? The unexpected results. So this is something very important. Whenever you are doing anything, and you are not getting what you were expecting, you are getting something different, just try to investigate and try to know the explanation out of that why it is happening. And just in some of the examples, I will show you that how the very, very important things have come into existence because of this quality. Okay, so I'm showing you a few more things. A cup of coffee or a sweet and low, and probably you can understand what I'm talking about. So the world's first artificial sweetener, benzoic sulfite. How this has come, see, the discovery of saccharin, is credited to Konstantin Fallberg. Somewhere in 1879, Fallberg was working with coal tar. See, one day he was working late and forgot to wash his hands before eating supper, the late evening dinner. He was amazed when he found that his bread tasted extremely sweet. Fallberg realized that a chemical which had been he was using in the laboratory had contaminated and sweetened the bread. He returned to the lab to find the source of the sweetener. And Falberg discovered that benzoic sulfamide was responsible for the sweet taste, and this chemical eventually became known as a saccharin. This is again, see, the serendipity. This gentleman Falberg, he was not looking for saccharin or something very sweet, which is going to rule the whole of the world in the coming years, and a substitute for sugar or something, a very powerful sweetener. But this has happened. And again, you see, that man was taking his supper and the bread tested sweet. He went back to the laboratory and tried to see that which chemical, in fact, it could be. And then he just identified that it was benzoic sulfamide was there. And in that way, the saccharin became a popular sweetener. There is a very small story with that. Two men, Ira Ramsden and Konstantin Falberg. These two, they were working on that particular thing, and they published a paper, a research paper on that. And but it was only Falberg's name that made it onto the patent. It got patented, and this gentleman, Falberg, removed the name of his co-author and the co-worker, Ira Ramsden. And Ramsden, got very much disturbed, and he later remarked, "Falberg is a scoundrel. It nauseates me to hear my name mentioned in the same breath with him." I mean, this Ira Ramsden, definitely when you are working together, you need to have some moral. So this story shows that whenever you are working with your partner, when you are working with your, the co-worker, co-researcher, you need to take into consideration their contribution as well, because otherwise, it's a very sad story. But it's fine, like the Falberg is known for the discovery of saccharin, but we need to know the name of Ira Ramsden also, who worked hand in hand with Falberg, but because of this Falberg's, smartness, I would say, and deliberately the name of the Ramsden was dropped, and this, gives a very bad story. So anyway, again, the Falberg story says that you have to be very observant, very keen for anything happening around you, and try to understand the reasons of that. Here I'm showing you a dog. There is one gentleman, and sandals, and the shoes, and this pant zip and all. So we just, in fact, you can understand we are talking about what we are talking about. Velcro. We are talking about Velcro. So, but what is the use of a dog and all? Burrs. See, you might have seen, in somewhere in a jungle or even in your place around, this kind of burrs. These are the sharp, they are known as the burrs. So Velcro, when we talk about Velcro, so a dog invented Velcro. If somebody says a dog invented Velcro, so it is something exaggerated, but dog did play an instrumental role in the discovery of Velcro. How did it happen? There was a Swiss engineer, Mastrol. He was out for a hunting trip with his small dog, and noticed the annoying tendency of the birds, when he was passing through that small forest or this outing, the birds to stick to its fur, and of course to the socks of, the scientist, the Mastrol, and so this is something very usual, if somebody takes his dog for hunting, for the morning or evening ride, and says, and something happens, you just remove the fur, the birds, and just move ahead. This is the usual tendency, but this didn't happen with Mastrol. What this Mastrol did, so Mastrol just, he was an engineer, and he just looking under a microscope, and he observed tiny hooks, this kind of hooks that stuck burrs to fabric. Somehow there was a hook between the burr and the fabric and the furs. So Mastrol experimented for years with a variety of textile before arriving at the newly invented nylon. Though it was not until 2 decades later that the NASA's fondness for Velcro popularized the technique. I mean, this is how thing goes, But let us see again. Velcro, which has, you just see, everywhere it is there. So much of use, the small technique, but how it was invented, how this the Mastrol, work on that, and he designed a very beautiful small machine, I would call it, the Velcro, and it is so much in use. But here, this one, we all know that if the NASA, anything comes from the NASA or anything comes from any big institute, if they get interested into something, so that is an advantage, and the other people also start working on that. So this is one of the serendipity. I mean, the Mastrol was not interested in doing any such thing, but it happened and he did it. Car accident, you see, it's nice to know that if you are ever in a car accident, this windshield probably is not going to shatter into the million little pieces. I wish this would not happen to anybody else, but we can see this picture. Whenever the accident takes place, and the glasses are broken, the windshield is broken. The glasses, they are not spurred, they just do not go anywhere like a bullet or something. Otherwise, it's going to be fatal. So just try to understand how this has happened, how such kind of glasses, are designed, and how this technology has come into existence, all because of serendipity. This man, the French chemist, Benedictus, Edward Benedictus, the safety glass, the accidentally discovered by this chemist from France, he dropped a glass flask coated with the plastic cellulose nitrate, and it did. See, he was working somewhere. He was holding a glass flask which contained the cellulose nitrate, and when it fell down, it did not, because it was it was in a dry condition, and it did not break. So this is how he realized that if the glass is put into the cellulose nitrate, that so when the glass is broken in any accident, so it will not be shattered and it will just remain there. So this is another good thing. You see, this fellow, he was working on something else, on cellulose nitrate. He didn't want to make any such car glasses, windsheets, but it happened. Okay, this is our kitchen utensil. Every kitchen almost, these days we know this is something very common. This is very common. So what is this? This is Plunkett. The scientist is Plunkett. So, and Plunkett was working on some chlorofluorocarbons. Chlorofluorocarbons, we know, that are used as refrigerants, but of course we understand they are the real cause of climate change. So he was an industrial chemist, Plunkett, and he was trying to improve the quality of chlorofluorocarbon. So when he came back to check his experiment, the next day in the refrigeration chamber, so when he saw the canister where he had kept the chlorofluorocarbon in the gaseous form that was supposed to be full of gas, but there was no gas inside the canister. So Plunkett found that the gas had gone away and leaving behind only a few white flecks. Let us see. He was working on what? To improve the quality of CFCs. But when he came back to next day into the laboratory, and the canister that was vanished, the gas was not there, only the flecks were there. So now what is the next? The new substance proved to be a very fantastic lubricant with an extremely high melting point and perfect at first for military gear, of course, and now the stuff found finally applied across the non-stick cookware. Teflon, we all know. Teflon is such a common name, but again, it's the result of a serendipity, because that material, was of a very good property as a lubricant, but at the same time, very high melting. Even if suppose it is a good lubricant, it could be used somewhere else, but it could not have been used for the kitchen purposes. But now it is having, because it has a high melting point, it is a very good non-stick cookware. This is, boys and girls, I would again bring to your notice that what Plunkett said about the serendipity. Plunkett often told students his mind was prepared by education and training to recognize novelty. These two things, please, and education and training. If the mind is prepared, if the mind is trained to recognize the new things, the deviations from the expected results, novelty. So that mind is possible, and that is possible how? If it is, the mind is prepared, I mean by education, it is educated and given a training. I hope, I mean, today's talk, probably you will start looking at from this point of view, that if whenever you get anything unexpected, try to investigate it, try to go into the cause of that, and then hopefully you will find something new. So this is what I was talking about, the Teflon discovered by Plunkett, and that to serendipity, it was again a serendipity. A serendipitous discovery. I'm talking about Alexander Fleming slightly later, because probably this is the most popular example of serendipity. We all know that Alexander Fleming got a Nobel Prize for what? 1945. He got it for antibiotic, the first antibiotic in 1928. Just think of the life before 1928 when there was no antibiotic, and how many people might have died, in the absence. But the beauty of the whole discovery is the serendipity and the aptitude of the scientists, to look at the deviated results, unexpected results. So it was 28, and we all know that this gentleman Fleming, Alexander Fleming, was working on. He was a bacteriologist, and he observed that the bacteria, in the proximity, in the closeness of the mold colonies were dying, as evidenced by the dissolving and the clearing of the surrounding of the agar gel. Those who have biological background, I'm showing you, this is the agar solution, and that is how, he was working. Okay, this is the paper. Just I want to show, how this paper was published by this Alexander Fleming. And this is the dish, the petri dish where the mold was there, and because of this mold, the bacteria was just keeping a distance from the mold, like that. Okay. This is, I'm showing, anyway, first let me show you. Yeah. This penicillin, So instead of cleaning or discarding the petri dish and ignoring the contamination as a mistake, okay, Fleming decided to investigate why the clear area had appeared. This one, this, okay, around this, why this was happening, that this was the thing which really he got interested into. So eventually he discovered that the mold or the fungus was making an antibiotic that killed the bacteria around it. And Fleming, in fact, identified this mold as penicillium and named the antibiotic penicillin, the first antibiotic. So that was the observation. Instead of, when he came back to laboratory and he found that there were some kind of, impurity was there, something, because of the window was open and something from outside, somewhere had the fungus was there. So instead of, he might have thrown it, into the sink, but he didn't do that. He just tried to investigate that what this is happening, why it is happening, why this mold, is just the bacteria, they're running away from it, And with that, he just realized that it is something, with that you can kill bacteria. So that is how, the penicillin has come into existence. This is the plaque, The plaque was put, somewhere outside the room of Alexander Fleming. So it is very beautiful. I just read out. This plaque commemorates the discovery in this room of the penicillin, okay, by Sir Alexander Fleming on September 28, to the glory of God and the immeasurable benefit to mankind. Of course, that was the first antibiotic, and just try to understand when there were no antibiotics, and to the glory of God, So the Bhagwan no Mahima, that is what says, Yeah, so they were thankful for that. Okay. I'm showing you a few more things, like, have you seen this? You probably in your undergraduate classes, you might have seen this picture, X-ray. Whose X-ray is this? Whose hand's X-ray is this? Discovery of X-ray in 1895, the Röntgen was performing a routine experiment involving cathode rays when he noticed that a piece of fluorescent cardboard was lighting up from across the room. Something again, he was doing something else, he discovered something else. So Ranjan expected a new type of radiation was responsible, and so he called them X-rays. X means unknown. And they could pass through the paper, wood, and of course skin also. So Ranjan took the first medical X-ray. This is the first medical X-ray. This is the first medical X-ray of his wife's hand. And now upon seeing the image, wife said, "I have seen my own death. Happy anniversary, honey." So this is a very punchline, and this probably, some of you must be knowing that this sentence, "I have seen my own death." So anyway, that was it. She said it jokingly, but this is the first, X-ray. And again, Ranjan was doing something else. He discovered something else, but this is how the X-ray has come into place. And now we are just using it like anything. Tire. See, the use of tire was very difficult. It was not that easy because, in initial days, when this kind of thing came, the plastic kind of thing, the polymer came, so to make use of them for this tires and all, very difficult because, during the winter, they are very tough. During the summer, they got melt. Let us think, that if in today, in your car, for example, in your car or in a bike, the tire, the melts in the summer time and they become very hard, in the winter. What would happen, So that is really a very difficult thing. But this when Goodyear, he was very fond. He was not very, a trained scientist, but he was fond of doing many things. So what happened? Today we are using the vulcanized rubber. So it was somewhere 1839, this man Goodyear, he accidentally dropped a mixture of rubber, sulfur and lead onto a hot stove. And of course the mixture got hardened, but was stable. And the world finally had a durable rubber resistant to both heat and cold. So again, I would say that this man Goodyear, of course, he was interested in working with this kind of thing, he was working with the rubber and all this, but he was not knowing that when a rubber is mixed with sulfur and lead, and these three, they just, will make vulcanized rubber. This is accidental. Usually how the experiments are done, there are procedures, there are things, today we know. Today we know it is written it is given in the literature that if you take rubber, you mix, sulfur. Even it is now quantified also that how much sulfur is to be added in terms of amount, how much lead has to be added into rubber to make a vulcanized rubber. But this man Goodyear was not knowing it. He was not knowing. He did not read anything into this book. It just happened. He was trying some trial and error. But when he found that some part has fallen, and he tried to see, and it was hardened enough and very resistant to both heat and cold. Okay, one more thing I will just wish to discuss with you, that is about Louis Pasteur. We all know what the Louis Pasteur did, but what he said is very important. He said, in the field of observations, chance favors only the prepared mind. This is very important. Chance favors only if you are prepared. See, in all the serendipity examples which I discussed with you, I showed you, they were on prepared mind. They knew their things. Of course, they were doing something else, but at the same time, they were prepared mind. So that is very important. That is what, the earlier Plunkett said, that it is possible by training and education to have keen observation. And if you have a keen observation, you can be very creative. And now, again, I would say we are into 21st century and national education policy stressing a lot on creativity, critical thinking. You have to be creative. Now, most of the things, simple things have already been done. And if really you want to excel in your career, whatever career you have to be very creative. You have to be very creative, and that is possible just by having keen observation. And once you have keen observation, you are a keen observant, so you will be a very good problem solver also. Wherever you work for, either you work for your own business, you work for any corporate world or anywhere, if you are keen observant, you will definitely be an asset to your institute, your association, or your establishment. So this is a good news. And moreover, creativity is not like innate. It may be innate, but at the same time, it can be inculcated. It can be taught. It can be learned. So, I mean, it's a good news that anyone can be creative and you can learn critical thinking as well. I'm showing you, the Kellogg's. How much time is there, Dr. Kayur? Can I speak for another 5 minutes?
We have at 11, sir. We have 15 to 20 minutes, sir.
15. So anyway, I will take another 10 minutes, fine, huh?
Yes, sir. Yes, sir. No issues.
Okay. I hope, the boys and girls, you are just, you are getting the message. These are the stories, but I think through story, we get the insights. That is very important. Otherwise, the stories is fine, we read and it goes away. I give one more example. Kellogg's cornflakes, we are all know about it, and it is very popular breakfast. From where it has come, how these people, they work for it. So Dr. John Harvey and his brother Will, okay, with Kellogg were the Seventh-day Adventists, and they were searching for wholesome foods to feed patients that also complied with the Adventist strict vegetarian diet. So, see, even 1894, there were people. They are fully vegetarian, and they are just trying to have some diet, for the patients because they were the doctors, so they were looking for some good diet, vegetarian diet, for the patients. So how this happened, See, so this gentleman, one of the brothers, will accidentally left some boiled wheat sitting out. It went stale by the time he returned. Now see, the whole wheat got stale, spoiled. So what would have anybody else would have done? Anything, the wheat is there and it is spoiled. Just throw it, that's all, and just get rid of it, and just feel sorry for it. Oh, it was the boiled wheat and just I left it out for some time. When I came back, it is spoiled. Rather than throw it away, see, the brothers sent it through rollers, hoping to make long sheets of dough, but they got the flax. They wanted to have a dough like this, with the wheat. But instead, because there was a roller, and it was the boiled wheat, so they got the flax instead of the dough. This is the dough. Okay. Now they toasted the flax. Which were a big hit with the patients, and they patented under the name granos. Okay. The brothers experimented with other grains, including corn. We are talking about the wheat. But now the corn flax that is of the flax of the corn. So first they got it accidentally with the wheat, but later on they tried it with the corn. And now see, the Kellogg company is so popular. I'm not advertising for any company because Kellogg's is a household name that I'm talking. There may be other brands also, but it is very pertinent to talk about the Kellogg, because it was invented by them, and that too serendipitously. Because see, they didn't want to do something like this. They were doing something else, but they got it like that. So anyway, so this is the thing. And I want to give one more example, which is very recent one. We all, got vaccinated recently, and luckily we are just over the pandemic and almost a normal life. But the role of this vaccine, is very important. And I just show you how this has happened, how good luck paved the way. So a bit of good luck from the dosing error. What happened, we all know. The vaccines were prepared recently, and a lot of experimentation and a lot of things were done to regularize it, that how much dose has to be given and everything, how much it is to be given. That is always very important. So this company, AstraZeneca and the Oxford University, to submit their COVID-19 vaccine for their regulatory clearance. So it was a trial and error thing was going. The British drug makers said that the vaccine could be around 90% effective when administered as a half dose followed by a full dose a month later. This is how they decided that a half dose followed by a full dose, and therefore with that you can have the 90% efficacy. The reason the half dose is serendipity, let's say the Pangalos, the head of the AstraZeneca research development, told the writers how it happened. The larger group who had received 2 full doses as planned resulted the efficacy of say around 60%. But what happened, in one of the areas where these vaccines were given, so the vaccine, those who had to vaccinate the people, they got a wrong news, that as if only the half of the amount was to be given and not the full 2 doses. And when the survey was done, the half dose of this vaccine was more effective as compared to the full dose. So this is again a serendipity. But the mind has to be prepared. You need to have a proper data. Whatever result they got it, they examined it. If suppose those data were neglected, so this finding would not have happened. This finding would not have taken place. So again, you see, even in the any time, because this is time, that this is a serendipity, that the half dose were more effective than as compared to the full doses. Okay. So serendipitous discoveries have been very valuable, as a few of them leading to Nobel Prizes. Okay, many times, the getting a Nobel Prize is not the aim of scientists. They just keep on working. And you might have seen many examples that even after getting a Nobel Prize, they keep on working. Sometimes they get the second Nobel Prize. Even if they don't get the Nobel Prize, they keep on working. So let us see what is the motivation, So if you are properly motivated, you just enjoy your work. There is no purpose of getting any. So what people call serendipity sometimes is just having your eyes open. Again, I am stressing because really, students, you are young guys. I wish, that there must be some takeaway from my talks today. And why I'm giving, there are so many other examples, but I have taken only some prominent examples. They are very interesting examples. And with that, definitely you will start thinking that you have to be very observant. So until we stumble across one such serendipity, and any one of you come up with something very new observation, and those observations, when they are put into a very, very scientific manner, you will find something new, and that could be of a great use, help to the society. We are really passing through a very tough time. It's the 21st century, and you all have to be a good problem solver. And you have to be a lifelong learner. Gone are the days, when reading something for once and that will help you for the rest of your life. This is not going to happen. You have to work, keep on working. You have to be critical thinking. You have to be critical thinker. Critical thinker means, like suppose you are a very creative person. And when you are a creative person, you will come out with some, maybe for a given problem, you may come out with 5, 6, 7 solutions. But which is the best solution out of those 5, 6, 7 solutions? That requires a critical thinking, how to eliminate, how to just keep away those who are not good, and just to get the best from that. So you have to be creative. You can be critical. That is also possible. You have to be very observant, and you have to be critical thinking. And once you have a critical thinking, you can come out with the best of the solutions. Thank you very much. Thank you.
Thank you very much, sir. It was a good session, sir. And your expertise is vital for us, yes, all of us, sir. For beginners or researcher or commerce, right, sir?
Thank you. Thank you. Any student would like to discuss anything, 5 minutes, I will be very happy, because, and in the sense, they might be having something in their mind. So why not to talk to them, 1 or 2, 3 students, if they want to speak there?
Definitely. Please.
Students, the platform is open for discussion now.
Student, please raise your hand. We will allow to talk. You can write in chat box if you have any questions or any guidance.
Sainath Karpe, now you can ask 2 questions. Hello.
Sir, you can go through question and answer in question and answer section. The students have posted some questions.
Can you read it out? Chat. It is in the chat box.
Yes, sir, it's in the chat box.
Can you read it out? I am not just going.
Yes, please. Chairman, please read it out.
Yes, sir. Shivam Dubey is asking how different trial and error is from serendipity.
How?
How different trial and error is from serendipity.
Yeah. It's a good question, really. See, trial and error is good, and this is quite scientific. Many times you have to do it, and during the trial and error, there may be serendipity. Serendipity means cycle. No? For one particular solution, for what happens, when you are working for a problem, you are looking for a particular solution. That is very common. But there is a possibility that instead of a particular solution which you have anticipated, you get something different. And that may be of the use, or it may be of more use. That you never know. But anyway, so you have to be very observant, because what you are looking for may not be the outcome of your trial and errors. That is what I feel.
Yes, sir. Thank you. Hemant Patel is asking to show slide of saccharine and braking thermometer.
Sorry. No, thermometer.
Yes, sir.
Yeah, what? See, thermometer, I dropped it, but that is a good example of breaking of a thermometer. But what happened, the good thing is, like, because of now today, we don't have this kind of instrument. We have very sophisticated instrument now. Gone are the days, when you are just putting, the thermometer into the very hot solution and trying to know the temperature, and with that, the thermometer broken, the mercury goes there, and we know the example that phthalic acid and phthalimide kind of things, the crystals came into that, that is again a serendipity. Probably he is aware of that example, that because of the broken thermometer, this phthalic acid or this phthalimide, that came into existence. So, but anyway, with the modern experimentation, this kind of serendipity is not much into practice now. Yeah.
Yes, sir. Reddy Prasad is asking, nowadays technology is going to computer science way, and how would you expect future of chemistry?
Yeah. See, computational chemistry is coming up very nicely. That is very true. And computer is helping a lot. And with this AI kind of thing, we have come a long way as compared to, but still, like lathe, and this cannot be replaced, to that extent. Although if this happens, there would not any laboratory work, and everything can be done on computers. So anyway, computational chemistry has come a long way, and because of the AI and this machine learning and all. But at the same time, lab is always there, chemistry is there, and synthesis, which is the heart of the chemistry. It is always there. It will there. I hope.
This is from Vedant Chawda, sir. He's saying few words on click chemistry with today's topic.
Yeah. Click chemistry is, it's a wonderful thing. New, sometime, we can have this kind of topic, and it's a recent Nobel Prize, and although people have been working on a lot. See, the combining of two molecules, by an organic synthetic chemist is a very wonderful tailoring kind of thing. How you can join two molecules, and you can have a better molecule out of that. So that is a click chemistry. Yeah. And similarly, organocatalysis, that is very similar to the click chemistry. Some other day, we can talk about it. Organocatalysis is very important. They got a Nobel Prize on that last year probably, and that is another very important thing. So I take leave, sir. Thank you.
Thank you very much, sir.
Thank you very much.
Neil, please share. Sir, we have one token of memento for you, sir.
Okay.
Please share, Neil. behalf of Ganpati University Parivar, sir.
Kritanyata ki abhivyakti. Thank you.
Thank you very much, sir.
Thank you very much. Some other day we can also, again, we can join. Thank you very much for calling me, inviting me. And
thank you.
So nice.
Thank you.
Thank you, Dr. K. Bhatt. Thank you, Dr. Ajay Gupta. Thank you, Dr. Amit.
Thank you, sir.
Thank you. Okay. See you. I'm taking leave. Can I go?
Yes, sir. Please, sir. Thank you.
Dr. Kayur?
Okay, thank you,
So nice
sir.
of you.
Can you please share feedback link and attendance link?
Okay, sir. Students, I'll
Thank you,
share
Ajay,
the
sir.
feedback and attendance